Hello, everyone. Today, we're excited to introduce Nullius Veritas, a Next.js application built for the BioXAI hackathon. Our core mission is to accelerate scientific discovery by tackling a critical challenge, the underreporting and difficulty in discovering null or inconclusive scientific results. Too often, these findings are buried, leading to duplicated efforts, wasted resources, and a skewed understanding of research. Nullius Veritas systematically analyzes scientific literature to surface these crucial, often hidden, null hypotheses and highlight areas where evidence might be lacking or contradictory. So, how does Nullius Veritas work its magic? It employs sophisticated, multi-stage AI-driven workflow, acting much like a diligent scientific assistant. The journey begins with our AI-powered query analyzer. When you, the user, enter a natural language research query, such as find potential null results for resveratrol and its effect on lifespan, this component springs into action. Powered by a Gemini model via a Jenkins AI flow, it intelligently extracts core scientific entities like resveratrol and lifespan. Crucially, it then generates two key outputs. First, a concise keyword string optimized for database searches, for example, just resveratrol and lifespan. It meticulously excludes instructional phrases like find null results to ensure precise database querying. Second, it constructs a list of targeted analytical prompts. These prompts preserve your original analytical intent, guiding the deeper AI analysis that occurs in later stages. For instance, identify studies that report null or negative results for resveratrol on lifespan. This dual approach ensures both search precision and a comprehensive analytical scope. Next, the workflow moves to the multi-source literature harvester. Using those AI-generated database keywords, this component efficiently fetches article metadata, titles, authors, publication dates, and available abstracts from multiple major scientific literature databases. We query PubMed for biomedical articles, AR14 for physics, computer science, and quantitative biology preprints, OpenAlex for its comprehensive scholarly index, and Core for its vast collection of open access papers. Each service is designed to transparently report no articles found if your query yields no results from that source, or an error if the API call fails. Once retrieved, these articles undergo an important client-side filtering step. This ensures that only articles containing all essential terms from our initial database search keywords in their title or abstract proceed to the next, more intensive AI analysis. Once the relevant literature is harvested and filtered, the AI null clue detector takes over. This is where we look for the subtle signs of null results. Another Jenkins AI flow, utilizing a Gemini model, takes the article text, ideally the abstract, or failing that, the title and metadata, as input. Guided by those specific analytical prompts generated earlier, it diligently works to extract the study's hypotheses, experimental designs, and key findings. Most importantly, it meticulously searches for any textual indicators of potential null results, like phrases indicating non-significant findings or limitations. The output is a structured object, detailing these extracted clues for each article. Following this, we move to conceptual knowledge graph construction. For each AI process article, this stage extracts basic entities and their relationships. Think of it as creating a mini graph for each piece of research. We then aggregate these per article components into a summary of the conceptual graph. This graph, though conceptual, highlights key entities like resveratrol, lifespan, hypotheses, and null clues, forming a visual and structured representation of findings. Finally, the AI pattern identifier comes into play. This powerful Jenkins AI flow, also powered by a Gemini model, takes the aggregated textual knowledge graph summary and your original research query. It then intelligently analyzes this rich data to identify broader patterns, such as conflicting results across studies, underexplored hypotheses, or significant research gaps that could suggest overarching null hypotheses. The output is a structured insight into these potential null results and their justifications. All these findings, from potential null hypotheses and their justifications to the relevant text snippets and the interactive conceptual knowledge graph, are then presented via our interactive results visualization. This intuitive interface allows you to explore the AI's findings, understand the evidence, and even delve into the underlying knowledge graph, helping uncover those vital, often overlooked, null results. In conclusion, Nullius Veritas is more than just a search tool. It's an intelligent assistant designed to enhance scientific transparency and accelerate discovery by bringing crucial null results to the forefront. We believe this can significantly reduce research waste and provide a more accurate picture of scientific knowledge, ultimately benefiting the entire scientific community and initiatives like BioDeos and the decentralized science ecosystem. Thank you.